we are late. Let's stay in schedule. So, OW2Con'15 framework for everything as a service. So not only virtual machines, network, but also databases, web servers, applications, and whatever you want. Here at OW2Con', I'm the coordinator of this R&D project, sponsored by the French Ministry of Industry. I'm the head of the Research and Development Department at OpenWide and data cloud expert. So, in order to stay in schedule, short introduction to OW2Con', fundamentals, and then a demo, big picture, and live action. So, a few numbers. OW2Con', it's a 3-year project, up to 2K18, 71 months, 5.6 million budget, 10 partners, 3 academics, 5 industrials, 2 associations. And the goal is to lower cloud adoption costs by breaking up barriers between its various implementations, layers, and domains, and especially domains that we will have demonstrators on: data center deployment, big data, and linked data. The question is how? Well, we will build on top of the OGF's OKI standard, Open Cloud Computing Interface, and bring to OKI the power of formal languages. So some research there, and a model-driven engineering approach. Let me, in a few words, depict the problem. What is the issue? Here's the cloud, 3 layers, a lot of components, a lot more actors even. So the problem is that developers use each layer of the cloud. They have different tools, there are different APIs, different languages. So there is no single tool, no single approach for each of these layers. It's even worse once you go, you get fragmentation. If you go into, for instance, all of the services that are provided platform level to applications, and when you go up to application, it's even worse. So there's no one-fits-all solution, because at the bottom of it, well, you have too many standards. You have well, OKI, you have Tosca, you have DMTF CME, and the most used of all is Amazon API, which isn't even a standard. It's an industry de facto standard. You can have a standard at the platform level. Everybody does platform because everybody does cloud. So everybody does that develops on the cloud does platform, but everybody does its own sauce. Each vendor has its own. And finally, at application level, well, it's just as diverse as applications are. So lock-in, all of us are locked in each of these red cells. Lack of ecosystem at the top. So why might OKI be the right solution? Well, the foundation to the right solution, because in OKI, it's very simple. Everything is either a resource or a link. And be it at infrastructure level, you've got compute resources, that's virtual machines, storage resources, that's disks, network links that provide virtual machines one to the other, but that can be true also at platform level, where you can have a database resource, a database link that provides a database to a container resource. And well, at application level, you can, again, modelize and configure either a deployment or any other configuration parameter, business parameter of your application. So that's why OKI is a meta model, and any kind of extension can be defined to support any kind of cloud configuration at whichever layer you want, whichever business, etc. So this one is is already defined. That's OKI Core. There are already some studies at this level, some standards to be that have been defined, which have to be discussed, etc., etc. So now OQR builds on top of that and brings to it the power of formal models. So what's a formal model? That's something that can be computed. And if you can compute OKI, you can validate it. You can generate samples, valid samples, examples. You can generate even, well, an editor to edit it, or graphical editors to edit it, or simulators, or bring it all together, or do refactorings, like going from a simulated cloud to an actual cloud on top of your own infrastructure, or on top of an externalized outsourced infrastructure, such as the one of Scalair, the infrastructure partner of OQR. So that's why we have very powerful tools. OQR Studio, built on top of Eclipse series by OBO, which is the French leader of modelization, and which provides different viewpoints on top of the same models. For example, so that DevOps can have their own editors with their DevOps icons on top of the same cloud configuration that pure developers, on the other hand, will have in an other representation using their own icons, like an Eclipse icon, which would probably shock poor IT operators if they saw it on the diagram. You've got tools, but you've also got a runtime. So this runtime uses a model runtime approach, an Heroku Erlang-based core, and an administration console. It's done by Activion and Scalair. And finally, we've got an integrated deployment component by Activion and UGIF. And all of that will be demonstrated on 4 use cases, from the traditional classical one, very used one, that's a data center as a service, to more hot topics like big data by Activion, linked open data by Pôle Numérique and OpenWide, and again deployment by Ilinagora and Activion. All of that obviously open source. OW2 is a partner of OQR. That's why we are here, thanks, OW2Con. Eclipse also, because of the tooling layer. There's also a standardization effort towards the OGF, obviously. We've got very strong links with the Open Grid Forum, which has created OKI. And we are helped by a 10-strong international scientific orientation committee. So this allows us to design cloud configurations, configure cloud components, be it virtual machines or applications, in the graphical studio in Eclipse, and then to apply our configuration to the cloud and create either virtual machines or well, resource schedulers that uses virtual machines, or platform components such as OpenPath that use maybe schedulers but for sure virtual machines, or again linked open data that's reusable data, like countries and organizations and cities. Everybody uses those in their applications. All applications asks user to choose a city, so they have this data already there, ready to be reused at the condition they configure the access or maybe the performance. So precisely, linked open data. That's the topic of my little demo here. So in a few words, everybody knows open data. Well, open data can't really be, is not that useful, because you can only use data sets separately unless they have been reconciled together, in which case it becomes linked data, linked open data if it was open data. So that's linked data. We have linked data in Oswillow Data Core because that's data that is shared between applications of the Oswillow App Store, such as users, organizations, cities, points of interests, request for proposals and so on. And so what would be OQware use cases? Well, OQware use case in the case of DataCore, it's DataCore configuration as a service use case. So let's, the linked open data user as a service, configure this service as it pleases him. For instance, letting the user configure its own data models, their rights and governance policy, define custom indexes to have custom performance on specific queries that the user wants to be optimized for his own use case, and even deploy dedicated data caches as a service. Well, with Oswillo DataCore is web architectured, so that means it supports just like HTTP client-side caches. So obviously, being able to do caches by just asking for it through an API, it's a very powerful means of being able to do anything you want with linked data. So here are two demos. A first one, which is an infrastructure demo. It's mainly just try to think about what could become the current Oswillo production architecture if it were to be migrated to Docker, because Docker is trendy, because Docker allows a finely grained control over scalability, maintenance, monitoring. So what would it become were it on Docker? And demo 2 is about governance of linked data projects. When we publish a linked data project, we want to freeze it, and that's a governance decision. So first, what would become our little production architecture? Here it is. We've got a load balancer here. It talks here to some Spring Boot code that's Oasis portal. It uses obviously a Mongo cluster here, Mongo Global 3.2.1, and all of that is obviously in various data centers. So we have designed using the Docker specific studio that has been developed in OQware. Sorry. We have designed the Docker alternative to our current production architecture. And obviously it's pretty, but at the same time, it can also be directly generated to the actual configuration that could be put in use and that could be deployed over, for instance, the Scala infrastructure, since the partner, the infrastructure partner is OQware, is Scala. So that's the first step in thinking about the next step in the production architecture of Oswillo. And then the second demo is about governance. So what we want is, what's linked data in OKI? Well, at first it's nothing. We have to model it. So us technology providers, Oswillo DataCore developers, have designed this extension where we say that we have a project resource and a model resource and a model to project link. Data models are actually gathered into projects to ease up governance and management. And once we have done that, we can generate some interesting information, such as we can generate runtime hierarchy configuration so that it supports this extension. We can generate text style documentation that's like API doc, wiki style. And all of this goes into SRC gen. Here it is, for instance, the textile doc of our extension. And then we have to set up the runtime. So I'm sorry, it's a prototype. Okay, it's only first year of the project over 3 years. So that means that the backend is a database, and it's not the actual Oswillo data core implementation. So when I will apply my configuration, it's not going to magically provide linked data as a service. It's only going to store this information somewhere. We still have some work. So configuring hierarchy is providing it with the extension configuration. So the OKI base extension and the OKI linked data extension. And then we can start it. So let's start it. Where is it? It's hiding. It's hiding. Okay. So let's start it. Hierarchy is live. So why Erlang? Well, Erlang, not a lot of people can write Erlang, but a lot of people uses it, since it's the language behind the 99.99% availability of Ericsson since the 80s, and it's in RabbitMQ, etc., etc., etc. So it's very fit for this purpose, that it's a cloud middleware. And now that we have done that, our runtime is configured and up and running. Let's actually, do our governance operation. So here is our current configuration. We have a geo_1 linked data project, which is about geographical elements like cities, countries, regions, departments. We have org_1 project, which is about organizations, business activity kinds, and so on. And as you can see here, we have a property, weirdly named frozen model names, which means that all models are frozen in this project. I mean, data models can't change, so you can write data in this project without fearing that it's going to be obsolete, that it's going to explode at some point because the model is going to change. And on the other side, org_1 has just been created, so while it has been drafted, and once it's been drafted, well, we just want to publish it. So let's again say that, let's star it. Let's put a star in frozen model names here. And that will say that nobody else, nobody can change those models anymore. So it means that we are gonna go from the left to the right with a star here. And here we have something very nice in OKiWare, very simple also, which is a curl generator, meaning that here I can generate curl scripts that will apply this configuration in the cloud. So that's what I've done. And now I'm just gonna call this curl script here. Here it is. Okay, I've got one project, I've got 3 models, great. And if I try to get here to have a look at this project here, we can see that oh, okay, demo effect. I don't know why there's no star here. Okay, there should have been a star here. It did work very well this morning. I'm sorry, I think I'm late. I'm gonna let Stefan take the mic again. It should have been this way. Sorry guys for the deception. Just to say that we still have a lot of stuff to do still in OKiWare. And not only this prototype, but also more generators and connectors, simulation, more technology-specific studios, generate hierarchy integration with Java, and obviously all the use case platforms. So keep in touch and stay tuned. Hopefully next year it will work.
We will stay tuned. Thank you very much.